Hello, everyone. Thank you so much for joining today's talk. My name is Tahai Chen, the Solutions Architect from AccelerComm, a semiconductor design house based in the UK. Today, I'm very excited to share with you our work on indoor-outdoor 5G O-RAN standards compliant split 7.2x base station acceleration. Now, the problems we face in existing radio access networks, i.e. RAN, are proprietary, expensive, and lack of innovations, resulting in all the disadvantage on the left you can see here. And with 5G commercial rollouts coming out these few years, we also face challenges such as algorithmic and architectural challenges around complex signal processing tasks, such as LDPC, implementation challenges around software and hardware co-design, and also optimization challenges around PCIe bandwidth bottlenecking data traffic between FPGA and the machine. Now, just to give you an overview of what we're talking about here in terms of O-RAN. So the component that we primarily focus on is the High PHY of the layer one of the one of the three major components of the infrastructure, i.e. ODU, distributed unit. And so for DU, state-of-the-art commercial off-the-shelf software solutions such as LDPC software only offers about 150 megabits per second per CPU core, which is expensive to deploy in base station. This is why FPGA acceleration is needed. And before we dive into details of our solution, the software driver for PCIe interface is harder than you think to implement. So at AccelerComm, we come up with a driver that achieves more than 90% of the theoretical throughput for the PCIe interface. Now, to accelerate the RAN, we have come up with a solution called PXSCH channel IP, as you can see on the right. And the innovation involved comprises proprietary algorithms to offer superior error correction, innovative inner parallelism architectures, and also all the modules that we talk about here are designed for 5G NR from scratch. We have PUSCH channel, which comprises CB LDPC decode, TB LDPC decode wrapper, polar decode, and also QAM demodulator. On the other hand, we have PDSH channel, which comprises CB LDPC encode, TB LDPC encode wrapper, and QAM modulator. Now, we have found a customer who is interested in our PXSH channel IP products. This is why we have partnered with Silicom to serve one of the network infrastructure solutions providers. And as you can see on the right, we have the picocell base station technical requirements, namely through GPP release 15, bandwidth has to be 100 megahertz, numerology 1, and most importantly, the peak throughput has to achieve 1 gigabit per second per RU for uplink, and 1 gigabit per second per RU for downlink when QAM is 256. And because we're talking about two different base station products, so we have one with 4x2 MIMO layers, the other with 4x4 MIMO layers. And for each, we have 2 RU to go with it. And these base stations target private networks and dense urban networks scenarios. Next, together with the PXSCH channel IP products, i.e. PUSCH decoder and PDSH encoder, plus polar encode chain and polar decode chain for PUCCH and PDCCH, also from AccelerComm, we have integrated all these IPs onto the Intel Stratix 10 S10DX FPGA on the Silicom Lightning Quick card to provide the layer one Hi-Fi accelerator function. One thing worth noting is that this Silicom card has PCIe Gen 4x16 connection, so which provides, in theory, 256 gigabits per second bandwidth. In terms of performance, we have to achieve the required throughput targets for LPC and Polar in order to deliver the required data rate for this small cell application. And throughputs listed here are targeted by 2RU42R and 2RU44R on the right-hand side. And more specifically, we are talking about LPC encode and decode, Polar encode and decode. And to deliver all these data rates, logic utilization on this particular FPGA is also listed here on the top bottom corner. More specifically, for 2RU42R, we only need less than 20% of LRMs and less than 10% M20Ks for this first base station product. For the second base station product, we only need less than 30% ARMs and less than 50% M20Ks. In comparison to our competitor solutions, a AccelerComm solution can save up to 5% on ARM and 30% on M20K in total, considering the same clock speed, i.e. 250 MHz with LPC and 150 MHz for Polar. Now, error correction is important. So this is why we care BLER performance, which is the key metric for error correction. And we have listed here 3 BLER plots for LPC base graph 1, base graph 2, and also Polar uplink. And for LPC, we are targeting BLER 10 to the minus 2. And for Polar, we're targeting BLER 10 to the minus 3. In terms of the x-axis of the plot here, for LPC, we are talking about K prime, and for Polar, we talk about A. And at y-axis, we are targeting SNR. So as you can see here that all these BLER curves comply with the 3GPP standards requirements, and we deliver outstanding BLER performance required by this base station acceleration task. Lastly, in terms of benefits and improvements, in summary, we only consume about 20% ARMs for 2RU42R and about 30% ARMs for 2RU44R. In terms of power consumption, because we use less logic and lower clock frequency, naturally, it translates into less static and less dynamic power consumption. Assuming dynamic power scales linearly, so we can save up to 38% power with LPC and up to 73% power with Polar. In terms of saving CPU cores, in comparison to the software LPC alternative, our solution can save more than 27 CPU cores. And in terms of costs, because we consume less logic, we can achieve higher numbers of RUs for 42R and 44R with the same card and same solution, but multiple instances of the IP to further reduce the NRE costs for our customers. Last but not least, in terms of further improvements, more complete signal processing modules can be included to achieve inline PHY to bring higher dB gain, such as 3 dB, to mobile operators because they care about dB gains. And also, higher hardware efficiency with higher clock speed can be pursued to address more challenging technical specs of base station acceleration. With that said, this is the end of today's talk. Thank you so much for listening. If you want to get in touch, please email me at taihai.chain@accelercom.com. Thank you so much for listening. I'll see you later.